So we have deployed our web application, our game, our finance app, whatever you want to call it. We have our DNS name of our load balance, but this finance dash, also my account ID, US East, ELB, AWS.com is not something that our end users will enjoy, right? People want to type some similar things like google.com, right? And here is where DNS comes into play. What we can do is we can alias this long, not friendly domain name using something better, something that looks shorter, more user friendly, and more concise. And this is, first of all, what we're going to do today. We'll create some DNS aliases in our web application for our config. Okay, everything got created, very good. And I will go ahead and add a couple more files to our configuration, and probably we'll put it into the load balancer model as well. Let's stick it into the same file, main.tf, but again, it's not prescriptive how you structure your files. Yeah, some projects might require one layout, some project might require different layout. That's solely up to you. And let me demonstrate you how Route 53 looks like before we start. You can go to Route 53. Route 53 is a domain registration service. You can host your public domains. You can purchase domains there. So I'll use one of my domains that I previously bought, and let me delete this. That's from our previous runs. So first thing first, I will obtain the data source. I will need some information about my Route 53 zone. So you'll have your own domain name here, one that you'll register. So to register domain, you just go to dashboard in Route 53, probably hosted zones, create, where it was. No, registered domains and registered domain. Yeah, .com costs $13, .net costs $11. That's a yearly price that you'll pay. We have this data source, and now let's create a resource of a type record. It will be resource route 53 record, and let's say www. Route 53 record is nothing but DNS record. DNS record means it tells your DNS server how to process DNS requests to some certain name. For example, like Google.com is pointed to, I don't know, 174.5.32.12. Let's say, for example, right? That will be an example of DNS record. Similar ones will have in our configuration. It will be, for example, www your DevOps mentor.net, redirecting to URL of our load balancer, like that. So what do we need for that? We need zone ID. So zone ID, what is zone? This is called a zone. A domain, registered domain, has a zone associated with it. Hosted zone, domain zone, whatnot. Here it is. And this zone is like a container for your records. And when you want to create records, it should live in some zone that's associated with some domain that you have. And for this purpose, we had our data source to obtain zone ID using just the name of our domain. Data, AWS, route 53, zone dot main dot zone ID. Also, we'll need name. This is basically what a user should type into his web browser when he wants to connect to a web server. It will be www, and the name of our domain, let's say data AWS route 53 zone dot main dot name. The type is CNAME. CNAME means there is one domain name that is pointed to another domain name. Other examples is, for example, a record with which points a domain name into an IP address. Time to live means how long it will be stored in your DNS cache and how often it will be updated. Let's say 300. For our example, it's not that relevant. And URL of our load balancer, it can be obtained using this property, DNS name. So it will point this into this. Let's save and run Terraform Apply. And yeah, never forget to create a branch. I had to reinstall Terraform, that's why it's giving me this error. Failed to query available providers, Terraform providers. Interesting. Just a second. It should be not Route 53, but AWS Route 53. We already have this record, even though Terraform still for some reason hanging. Let's test it out. We can use the command called dig. What this command is doing is it's showing you which DNS record is associated with the domain name that you're querying. And basically, we can do it for any domain, by the way. We can find out about Google.com, for example. And you can see that Google.com is associated with this set of IP addresses through the A record, which points domain to IP address. In our case, that's CNAME, CNAME record of this pointed into our finance load balancer. Let's test it out. Here we are. Hello from instance, and basically it will be same, almost the same, since we have a load balancer that returns different URL, different numbers all the time. But this time it was identical. This is how we configure the DNS in Amazon Web Services. Let's commit and add and commit. Okay. Now the situation. I will open floor for further assumptions. But first, let me describe the use case. Imagine we are working as a DevOps team lead. We have, together with our team, built this infrastructure. Final improvement was to add DNS name. We launch it into one production, and the next day, security guy comes to us and yells at us. Why is that? Why he is mad at us? What we forgot? Very, very important, crucial, very like essential step for any production deployment. Sanjeev?
SSL enabling this URL.
Yes, that's right. Totally right. No one runs websites without SSL in 2023, even 20. But yeah, maybe in 2010 there was some sites without SSL, but right now it's de facto standard. And yeah, we can configure these as well. And I will show you the easiest and I would say simplest way to provision SSL without having to pay hundreds or thousands of dollars for certificate, without having a hassle of maintaining certificate. In AWS, there is a service called AWS Certificate Manager. And this service, especially, it is extremely powerful when we're hosting our domains on Route 53. It allows us to issue certificates and to assign it to our load balancer and to our domain names. So let's configure this feature. Git checkout -b. The service called Amazon Certificate Manager, or ACM. No, did I pull? Yeah, I did. So the first resource will be AWS ACM Certificate. The name will be like whatever name we would like. Let's say main. To point it to our domain name. Certificates are not only for encryption, but also for verifying that whoever has this domain is actual owner of this domain. That's why each certificate that you need requires having a domain name. Validation method, DNS. Again, yeah, since I mentioned, a certificate requires a domain. In our case, that's Route 53, and we must prove that we own this domain. And we can do this by receiving special email to the address that is specified in our domain settings, or by creating a special record in DNS. And we will go through the record route because it's easier to automate this record through Terraform. And then let's create the one more domain record, which will be used, just as I explained a second ago, for domain validation. And this one is a very interesting construction. It is using for each loop. So basically, the certificate will give you several properties of for domain validation. And what they are doing is that it is going through each of the property and pasting it into the proper record. And no need to worry regarding this for each loop. We'll cover these more complex statements for each dynamic blocks, the rest of stuff later in the next sessions. For each open, close, yeah. And a couple more options required for this particular record. You might wonder how do I know it? And the answer is from documentation. Let me show you the exact example that I've stolen. I did not written it myself, so you don't have to be intimidated here. Let me demonstrate. Terraform ACM certificate. This one, when we go to Google and search for this resource, in the example parts, it gives you this. It gives you exactly this example of how you validate certificate using ACM certificate validation resource and the required record. And in fact, let me just actually copy paste rather than type, and just go through it and explain what's happening. So once again, yeah, our ACM certificate has the property of domain validation options. This Route 53 record resource will go through each property in this object and create proper record types. Couple more things, and the ACM Certificate validation resource where we point our certificate to the corresponding domain validation records that we created using this construction. And again, no worries regarding if you don't understand for each. Not everyone understands for each. Even mature, experienced Terraform professionals have troubles with it. And we'll have a separate session where we'll dive exclusively into these advanced constructions like for each and similar things, but not for now. For now, we are focusing on certificate, domain validation, and the rest of things. Yeah, let's run Terraform Apply. Let's hit yes. And while it is creating, there was a question from Ahmed. What the question is, what if the domain name is not from AWS Route 53? Theoretically, if your domain provider is modern enough and has interface, there is a chance that there is a Terraform provider for it. For example, there is a very popular domain register GoDaddy, and there is Terraform provider for Terraform provider for GoDaddy, for example. You can do the same in your in your GoDaddy domains or whatever register you have. If there is a provider available, you can use this. But you won't be able to use ACM in case you have custom domains. You'll need hosted domain hosted and registered to Route 53, or at least you need to delegate subdomain. Validity of certificate is these certificates are renewed automatically. Boris, yes.
So the certificates is sort of like a value add if you're hosting through Route 53. I mean, or are you paying for them extra?
You're not paying for them. These certificates come for free, no cost.
Gotcha. And they do wildcard certificates as well?
Yes.
Nice.
And there is one more thing we need to change. Since we have HTTPS now, obviously we could open HTTPS port on our load balance. And yeah, actually one more thing we completely forgot. We also need to not only add this certificate and associate it with our domain, we also need to configure our load balancer so it works with HTTPS. And how it's done. Let me create some diagrams for that. We have our user who connects to, for example, www.domain.com. Each has load balancer behind it. And the load balancer serves traffic to our auto-scaling group. Let's say instance 1, and also one more instance. That's the traffic flow. So there is a feature, and I would say overall concept of certificate termination. What that means? It means a user connects to the domain name through the secure protocol through HTTPS. And let me mark it with green. It is redirected to the load balancer and also in the encrypted form. But what load balancer is doing? Load balancer over here is decrypting this traffic and forwarding further requests as HTTP. Basically, we are installing our certificate into our load balancer. And over here, it comes in a plain HTTP. And you might think that it's not secure enough, but in a lot of cases, that's just enough. Because the backbone, let me, for this, I will take some better shape, 1 second. Because this traffic is not open to the public. It's not open internet. It's running privately within your own container within AWS infrastructure. And you can kind of consider this as a trusted perimeter. You can trust AWS, and it will promise and maintain this commitment that no one can, for example, jump into here and sniff your traffic. It is, as I mentioned, very often that's acceptable, but sometimes, yeah, you require full encryption, then you have to install provision real certificates, not ACM managed, and install them directly onto your instances. Yeah, for example, if you deal with credit card data, PCI compliance requires full encryption across the entire route. But like, for example, if you host a web game or, I don't know, some image gallery or something like that, that's not that critical, and you can easily go ahead this route. Okie dokie. And yeah, then let's reconfigure our load balancer. Just give me 1 second, I will check my notes. Yeah, very good. We can move forward. So let's open our load balancer code. And instead of port 80, we need port 443. That's secured HTTP or HTTPS. This one we will not change because otherwise it will force us to recreate entire security group and bunch of things as a dependency. Target group will still be pointed at port 80 because that's what basically happens between load balancer and the instance itself. And in our listener, we need to configure some. That's the place where we point our certificate. And 1 second. For some reason, I'm not able to find the proper hint in my cheat sheet. Yeah, finally. So the port will be 443. The protocol will change it to HTTPS. We will also need to add the certificate to our listener. This is the place where we are installing the certificate. It will be AWS ACM Certificate main.rn. And I'm doing this by memory. Hopefully this will work. And SSL policy. Yeah, let me copy paste this property. I won't be able to spell it out loud like this. Let's try running Terraform Apply. Paris, yes.
Where did the SSL policy come from?
There are a bunch of SSL policies supported by by ACM. We can find the list of supported SSL policies in the documentation over here. I will admit I have no. I'm not that security expert. Have no idea what's the difference between them. Some of them probably most recent, some of them less recent.
Gotcha. Thank you. I just wanted to see where I can grab that information from.
Okay, it applied, and let's test our HTTPS then. Yeah, very good. Now we're connecting through HTTPS. Let's test it out in the browser as well. And we see this nice and beautiful secure log that our traffic is encrypted and no one will steal our password, social security number, or whatever information we provide. And Boris, yeah.
Sorry, could you click on the lock? I just want to see what their certificate looks like.
This one?
Yep, so it is that. Yeah, I was just curious. I've never seen it before from Amazon ACM.
And myself had a lot of trouble. I would say I was avoiding dealing with HTTPS for a while. Before I discovered ACM, I didn't want to spend pretty significant money, at least like $100, to buy real domain and real certificate. And I was kind of avoiding it, not trying to do anything but this part. But with ACM, it made creating secure websites for your labs, for your projects, of course, extremely simple and easy. That's one of the best services that I extremely enjoy about in AWS. As usual, don't forget to destroy your infrastructure. And if we don't have anything to discuss, we are good to go. Otherwise, please